So, good morning. Welcome to 511 Live. For those of you, this is not a deja vu for you. I did start at 7:30, but I think because of the link, my apologies. We were going to do the Molly Pals, but we're actually going to do a Bag Fabrics 101. So for those of you that have watched it since 7:30, you probably need a refresher, so I'm going to refresh you a little bit. We're going to just start from the beginning one more time. So as a reminder to everybody, believe that there's a link where you can kind of see the slides that I'm going to go through, and you can post your comments or ask questions, and I'll do my best to answer them for you. But it's just an opportunity to give you an idea of just some real basic idea of why we choose the fabrics that we do for our bags, what the difference is between why we choose a nylon versus a polyester, what does the D mean when somebody says 1000D, what's a Dobby, those types of things, and what kind of testing do we do, and why do we choose the fabrics that we do. So I'm going to start off right now with nylon versus polyester. So nylon versus polyester, both fabrics are basically a synthetic, which means that it's a substance made by some kind of a chemical synthesis. So they start from a chemical liquid, liquid base, and then they're spun and dried into fibers. So I'm going to go through this list here. We'll look at nylon first. So nylon is manufactured, it's a polyamide which is made from a petroleum. The strength is exceptionally strong, and this is the reason why probably 90–95% of the products in this category are made with a nylon. The abrasion resistance is very good. I put here better. In this case, it's going to be better than your polyester. Your chemical resistance, it's resistance to damage from oil and many other chemicals as well. The wearability is that it has low moisture absorbency, and the UV resistance is pretty good. Given all these features, you can imagine that the nylon in general is going to be higher in price point. So this is the reason why our price points are a little bit more on the premium side. But again, it's because we're choosing a premium fabric here, or a premium material. So bags like our Rush series, of course, are made from a 1050D nylon. Moving to polyester. Polyester is meaning many, and ester is a basic organic chemical compound. Manufactured polymer derived from either coal, air, water, or petroleum products. The strength here, put here strong, because it's not quite as strong as the nylon, but it's obviously still very strong. The abrasion resistance here is good, not quite as good as the nylon, but still very good. Chemical resistance, it is that it's resistance to most chemicals. And the wearability is that it's wrinkle resistant. This is the reason why many apparel pieces are made from a polyester or a blend of polyester with another fiber. And the UV resistance here is actually superior to the nylon. And the other main reason why many choose polyester is just because the price is just much more affordable. It's much more widely used. So for our purposes here, we have our Rapid series, we have the Rapid Origin, Rapid Quad series, for example, priced at the $84.99, $89.99. Those are made from a 600D polyester. And the reason why we're really able to achieve that price point is because of the use of the polyester versus the nylon. So as a general summary again, nylon is going to be more expensive than the polyester, but it's going to be stronger, more abrasion resistant, more resistant to chemicals. But both are very good materials. But again, this is why most people in this particular industry will choose some type of nylon. Reminder again, any questions, any comments, happy to answer them the best that I can. We'll move on to the next slide, where we'll talk about this funny looking word, denier. So the denier, if you if you hear people saying 1000D, 500D, it's a common thing that you've probably heard, but you're maybe always wondered what it means. So the denier is obtained by weighing 9,000 grams of the yarn or the thread. It's expressed in a result of grams. So something that has a higher denier is generally going to weigh more. So a lot of times people will understand the denier to mean the size of the yarn or the thread. And that something that has a higher denier is generally going to be thicker or tougher. And it looks like I have un questione. Can nylon or polyester be turned into FR with some kind of treatment, or would that be a whole different material? So again, I didn't mention this to the newcomers. I'm not necessarily the most fabric expert, but I believe that the FR is a treatment in the yarn, which makes it FR. So it would be something that would be treated initially before it's made. But if I will double check that and confirm that. And I have another question. Where do they stand from a breathability perspective? Both are very breathable. As you can imagine, they're both wovens. So you're going to see in an extra slide later, the way that they're weaved together obviously allows for breathability through it. The nylon tending to be a little bit thicker in the weave is going to probably not be quite as breathable as the polyester. The polyester will tend to be a little bit thinner as well. As far as another question here, does the polyester tend to fray more easily than the nylon? I believe that the nylon, because of the strength of the yarn and the material itself, that it's more abrasion resistance, it's going to fray, or the abrasion resistance, because of that, it's not going to fray quite as easily as the polyester. Hope that answered your question. Okay, I'm going, just kidding. I got a finger that says, yes, it is. If I misspoke, that's what I meant to say. So denier is measured with 9,000 meters of the yarn, but it's generally resulted in grams, or expressed in the result of grams, excuse me. So for example, if you have 1,000 D material of nylon, you're weighing 9,000 meters of that yarn, and it should weigh about 1,000 grams. So that's how denier works. So yes, William Barry, you are correct. One denier is a 9,000 length of yarn that weighs 1 gram, correct. So in the picture in the PowerPoint presentation, I have a kind of a picture of about a 600D versus a 1000D. You'll kind of see that the weave is a little bit thicker in the 1000D than it is a 600. Our Covert 18 backpack, for example, is made out of a 500D, while our Rush series is made out of a 1050D. So the 1050D, the Rush will feel generally a little bit heavier. As you look at the weave, it'll look a little bit thicker. And that's basically what denier is. So if you have any questions about that, let me know. So just another side little note is that like our liners inside of our bags are generally anywhere from a 210 to 420 D. So they're going to be much thinner, much lighter, and thus the reason for using them internally inside the bag for a liner. They're going to be more lightweight, but they'll still give you some of that abrasion resistance that you need inside the bag. Rick Fox, you're asking me about hydrophobic. Are you sure you even know what the word hydrophobic means? I believe, yes, the polyester is more hydrophobic than nylon, which I had put down here also on this guy, is that the wearability of the nylon is going to be a little bit more, doesn't absorb as much moisture. And the same for, both of them are going to be very good with not absorbing so much moisture, but yes, the polyester is more hydrophobic than nylon. Okay, moving on. We're going to look at some fabric types or different fabric weaves. So the first one we're looking at is on this PowerPoint presentation is a plain weave. It's going to be our most simple, most common type of construction. It's very inexpensive to produce. It's very durable. It's flat, tight surface. It's conducive to printing and other finishes. Most of the fabrics that we use have a plain weave. We do a couple of different weaves like a Dobby or ballistic, and I'll go through those later. So this is the image that I was mentioning a little bit earlier as far as how the weave is made, and you'll see that there's a weft excuse me, a weft and a warp. And that's basically, you can see the weft is going and weaving through the vertical warp of the yarns or threads. The next one that we're looking at is a ripstop. So this is generally, you can see this particular picture I picked, you can see, in this case, it looks like a diagonal pattern here. So those diagonal ones, kind of the more brighter yellow pieces, are those thick reinforcement threads. Those thicker reinforcement threads are interwoven, usually at a regular interval. Here you can see this kind of diamond pattern. In a crosshatch pattern, resistant to tearing and ripping. So the reason why you'll see a lot of more outdoor packs kind of using this ripstop is that it's going to be generally lighter in weight. They can go a little bit lighter in the denier, but because of the reinforced thread in these intervals, that it prevents it from ripping more than it would just like a general plain weave. So this is one of the reasons why we use a ripstop. The next one is going to be called the dobby. Okay, sorry. Dobby, this is going to be a more complex weaving pattern. This dobby, for example, we use in our igniter backpack. It's made on a dobby loom, and what it does is that it raises and lowers the warp threads. Again, the warp threads are the horizontal threads. As they pass over the weft. I think I just messed that up. Wait a minute. Loom that raises and lowers the warp threads, which are the vertical ones, excuse me, as they pass over the weft ones. What it does is it enables usually some kind of complex patterns, and that's really one of the main features about a dobby. So if you look again at our dobby, and I think I tried to show a little imagery of actually our fabric on the igniter, you can see that that's why there's these cool patterns and textures, again, used on this particular bag. Lastly, I have a ballistic. Ballistic that we use, for example, on our luggage pieces like the cams and soms. This is used basically using a basket weave. It's either a 2x2 or a 2x3 basket weave, and it's a particular very tight, dense weave that maximizes the fabric's durability and tear resistance, which is again why we use them in our luggage pieces. They're generally made from a high denier nylon. It's going to be anywhere from 1000D, usually higher. I believe that the one that we use on our luggage pieces is 1680D ballistic. So you've probably heard that term before. But again, these are just some overall different fabric types or weaves that we generally use. So if you've heard some of these terms when we call out a fabric, this is the reason why we choose them. Any questions, comments? I'm fine if you don't ask me more questions, really. But if you do, it's okay. I'll do it to my best. And if I will recheck my answers just in case. So I'll let you guys know if there's any other discrepancies there. So don't forget to follow along in the email and in the link. Next one, I'm just going to talk about some coatings and finishes that we use. The first one is going to be a PU coating. This is a coating that we use on the back of every single one of our fabrics. Every one of our fabrics use a two-time PU coating on the back. What this is, it's a polyurethane coating. What this does is it makes the fabric water resistant, not waterproof, but very resistant to water while remaining very lightweight and flexible. So if you can imagine, if you take a chance to look at your bag, look on the inside of the back side of the fabric, you may or may not see kind of a little bit of a sheen to it. That's basically that PU coating, but the material is still going to be very flexible. But it's really just an opportunity to make the fabric a little bit stiffer, but provide that water resistance that we need. The next one we have is a TPE coating. This is commonly used, could be used on both the outside or the face of the material or the back side of the material. It's going to be more water resistant than the PU. TPE stands for a thermoplastic elastomer. It's not going to be quite as it's going to be more durable than the it's not as durable and flexible as the PU, but it's going to be more expensive. I think the water resistant feature is one feature that people choose the TPE over a PU. It's generally a little bit stiffer. I believe that we use it in some of our patrol bags. Generally speaking, we don't use the TPU just because the durability is not as great. But it is, again, going to provide that extra water resistance than the PU is. The next one we have is a TPU coating. This is a thermoplastic urethane. Of the coatings that are generally used in bags, this is going to be the most abrasion resistant. This is a waterproof coating. It's going to be very durable, but it's going to have the least flexibility. But again, this is going to be the most expensive of the coatings. This is a coating that we're actually going to potentially use on some EMS bags that we'll have in the future, needing kind of that waterproofness that they can easily clean the bag. So this is something that we would use on definitely higher price point products that really need that waterproof coating on them. The last one is a DWR finish. All of our fabrics also have a DWR, which is a durable water repellent finish. If you guys remember, Sandra did talk about this earlier in her presentation. So it's a polymer applied to the face side of the fabric that creates, in this case, this particular website called them microscopic pegs that encourage the water droplets to form and bead on the top of the fabric and allow them to basically run off the fabric and not soak through. So again, all of our fabrics have at least a PU coating on the back and a DWR finish on the face of the material. In some cases, we may choose to use a TPE coating on either side or a TPU coating as well. Again, PU coating is going to be super flexible, is really the standard in bag manufacturing for the backside of all of our fabrics. And that if you want a little bit more water resistance, you go to the TPE, or you really want to go waterproof and are able to go to that higher price point, you're able to go to the TPU coating. Okay. I think I have a question. Rick? That's good. I wouldn't say that Rick is asking if the TPU coating adds significant weight to the bag. The coating, because it's going to be a little bit thicker, certainly is going to weigh more than it would a PU coating. I wouldn't say that it adds a significant amount of weight. I would say that you're just really going to feel more kind of the stiffness of the material itself. And most of the time, whenever, again, in the application that you're using the TPU coating, you're probably needing a very significantly strong and durable bag like an EMS bag, or for like a surf bag of some sort, need to have that waterproof, or a dry bag. So people are not necessarily so concerned about the weight of it, but really the fact that it's going to be waterproof. So if you want that dry bag because you want to stick your wetsuit in there, or EMS because you're in the dirt and the rain and whatever, those are the instances that you're going to use that. So hope that answers your question. Flying through this. Okay, where are we going now? This is my last slide here. So I wanted to go just to give you an idea of the kind of testing that we do on our fabrics. You can kind of see the reason why we choose what kind of finish we're going to use, what kind of coating, what kind of denier we're going to use, and what type of material as far as nylon or polyester. So every one of our fabrics, our trims, even the finished goods go through a ton of amount of testing. Luckily, we have a lot of third-party testing that we can use. Our vendors and our suppliers can also do the same. So for fabric example, there's approximately up to 15 different tests. Just kidding, I'm going to wait 1 second. I have a question about which coating we use in our footwear pieces. I unfortunately cannot answer that question for you, but I can get somebody that I know sits right next to me to answer that question for you. But I'm 100% sure that they also have some sort of coating, especially on a footwear piece. You can imagine that they need that waterproof or that water resistance. So I will find out which coating type it is. Thank you for the question. Okay, so back to fabric testing. Approximately about 15 tests that each and every single one of our fabrics go through in order to be approved of our products. So I just listed out some kind of the main ones. There are obviously much more. So the first one is a tensile test. I'm sure most of you guys are kind of familiar with this. It's really the ability to withstand a longitudinal pulling force. I do not have any videos for you here, but basically we have a fabric that's clamped in between. You'll have a tensile tester that will pull it at a prescribed speed. Once that the machine will be able to detect once the amount of force or that tension changes, and once it does, then that's basically when the fabric does break or tear. So every one of our fabrics have to meet a certain type of requirement for the tensile strength. Again, different products, different applications may change in what that tensile test strength needs to be. So the higher strength materials need to have a higher tensile strength, but maybe our lower price ones, we're able to go with a little less tensile strength. Our next test is going to be the tear test. And this is the ability to resist further rupture after a tear is started. So it's kind of hard to see in this little picture here. There's a white piece of fabric, and you'll see on the top there's a little notch out. That little notch is also on the bottom portion of the fabric that you can see are in between those two silver clamps. And then you'll see on the left there, there's kind of that kind of quarter part of a wheel. And what happens is that wheel is connected to the left silver clamp. So that weight of that wheel basically gets dropped. So as it drops, it actually ends up continuing that tear in between. So the right clamp stays in place. The left one will swing as the weight of that machine goes down. So again, it's the ability to resist further tear. So once a tear starts, the ability to resist it from tearing even more. The third test is going to be our abrasion resistant test. This is the ability to withstand rubbing applied to the surface. So in this particular case, I have a machine here. There are a couple of different tests or a couple of different pieces of equipment that can use, but they basically do the exact same thing. So in this case, you kind of see this circular, this round kind of metal piece. What happens is you'll basically put some type of rough material, kind of like a sandpaper material, and that wheel spins over a piece of fabric over a certain amount of time. So basically the operator will check it after a certain amount of cycles to see how much the fabric below is getting abraded. And I have a question. Do we have some sort of documentation on each of these tests for our fabrics? Many of our team members can use this information for public safety contract bid processes. Yeah, so absolutely. We do have testing on each of the fabrics that we do use, and we can provide that information to you guys. So one thing that we do on a caveat note is that we will provide you the results, but as a rule of thumb that all of our testing, we do redact all of our testing procedure or results. So you won't necessarily see our internal specifications for how much tensile strength something needs to have, but we can, in our bid specs and on those types of things, give you the information of how much strength it is able to withstand. Next, we have color fastness. So this is the ability for the fabric after it's been dyed to resist a color change under some specific condition. So we can do a color fastness to water, we do it to light, perspiration, crocking, meaning how if it transfers to another material. So these are all things that we do to make sure that when we dye a certain material or fabric, that it's not going to have an issue when you're wearing it in the rain or you perspire with it on your back or on your shoulders. Certain colors tend to have better color fastness than others. Certain like bright neon colors tend to have worse color fastness. But this is a test that we do for any new material. And the last one I have is the flex resistance. This I put here is actually for able to retain physical integrity when you're subjecting it to basically repeated flexing. So the reason why I put this here is that in cases of opportunities where we have like a TPU coating. I mentioned that the TPU coating is very abrasion resistant, but because of that flexibility is not quite there compared to like a PU coating. If you continue to flex it or you continue to bend it over and over and over again, the delamination or the ability for it to crack after long periods of time is going to be higher than the PU coating because it's going to be thinner and more flexible. So this is something that's this type of test that we would do on certain coatings. And that's, again, just a overall view of some of the fabric testing that we do. These are all testings that we would do on apparel fabrics as well. So this is not specifically just for our nylon bag materials, but it's really just a snippet to see that everything that we do is with purpose and with meaning, that we're very strategic on what we choose to use, and that we make sure that for the application that it's being used for, that it's going to withstand the environment and the applications that these guys and girls are using it for. So that's all I have, but I'm just going to give a brief kind of overall summary again of what we went through. So again, we use a lot of nylon and we use a ton of polyester too, but mainly 90% of our products are going to be with nylon, again, because the chemical resistance, the abrasion resistance, and the overall strength is going to be a little bit higher on the nylon versus polyester. And it's widely used in the industry. A majority of people within the industry are going to use the nylon versus the polyester. Denier, so when you're talking about 1000D, the denier is basically relatable to the size of the thread or the yarn and the overall weight of it. So the higher the denier is going to be a little bit thicker and tougher. So the more premium products or the applications that are used that are going to be more stringent versus maybe more of a back to school, like everyday backpack, is going to have a higher denier than those. Fabric types, there's tons of fabric types, but mainly we use a plain weave, like our 1050 is going to be a plain weave. But there are many other different ways to weave the yarns or the threads. So ripstops are generally going to be lighter in weight because of the ability for it to tear. So outdoor bags are going to generally use a ripstop, so they'll be lighter in weight, but they're because of the reinforced thread in that repeated pattern will prevent it from tearing. Adobe allows us to really use a lot of variable patterns and textures while still maintaining that strength. So Adobe is something that we decided to use in our igniter backpack, for example, and is actually something that we're going to use in a future season in fall 18. And the ballistic is definitely that tight and dense weave that's going to be at least 1000D or higher, giving you that strength, which is why we use it in our luggage line. Coatings and finishes. Every single one of our fabrics have a PU coating on the back, which gives it the water resistance and a little bit more strength, but it still maintains that lightweight and flexibility that we need. Everything also has a DWR finish on the face of the coating to, again, give you that water resistance. Again, but over time, it's obviously going to, degrade with use. But every one of our fabrics come with a PU and the DWR finish. But there are opportunities for other coatings, such as a TPE or a TPU, depending on the application that you're going to use. But as we go in higher durability, higher waterproof rating, you're going to go higher in cost. And lastly is the fabric testing. Fabric alone goes up to maybe 15 different tests that we do to make sure that it's strong enough, the color is going to stay on there, that it's not going to tear, that over time it's not going to fade or crack under a certain amount of load. So we do tensile testing, tear testing, abrasion resistance testing, color fastness, flex resistance in some cases as well. But it really is just a taste of the different amount of testing that we do for our fabrics. So not only do fabrics, we do trims on their own, have their own testing. Then we actually have finished good testings as well. So once let's say the backpack is assembled, we do more testing on that to make sure that the construction of it is appropriate for the load that we want to use on that particular bag or backpack. So that's all I got for you. I hope that was somewhat informative. Hope I didn't confuse anybody or accidentally say the wrong thing. So please direct all questions to Brendan Rin. Just kidding. I'm just kidding. I'll ask him about the footwear question, but feel free to send questions. Always willing to learn myself more about this stuff. So any questions is welcome. And also send me things about other things that you would love to learn about bags in general. I'm happy to have me or my team or anyone else that we can bring in to kind of help you guys, equip you guys with more information, so we can sell more and do better. Okay? So you can still write comments and questions. I think I'll still be here for a little bit, but you won't get to see this anymore. Okay.